The National Electrical Code, specifically Section 406.4 C2, addresses the installation of faceplates for flush-mounted receptacles or switches. This section mandates that faceplates be installed so the grounding terminal is located at the bottom. This code requirement ensures that the grounding prong of a plug is the first to make contact with the receptacle. This reduces the risk of electrical shock. It is also common practice to install grounded 110-volt receptacles vertically with the grounding prongs located below the line 1 and neutral spade inserts. Firstly, the specific orientation ensures proper grounding. Proper grounding minimizes the risk of electrical shock. Secondly, the specific orientation allows for easier plugging and unplugging of devices, as the grounding prong is easily accessible. Thirdly, this specific orientation creates a more visually appealing appearance because the grounding prong is somewhat hidden behind the faceplate. In some cases, it may be necessary to install a receptacle horizontally due to space constraints or other factors. It is important to note that the grounding prong should still be located at the bottom of the receptacle to comply with code requirements, regardless of whether it's oriented horizontally or vertically. The primary reason for this requirement is safety. When the grounding prong makes contact first, any fault current is safely diverted to ground, protecting the user from potential electrical shock. This principle is fundamental to electrical safety and is consistently reinforced throughout the NEC. The NEC serves as the definitive standard for safe electrical installations in the United States, and compliance with its provisions is essential for protecting people and property from electrical hazards. Section 406.4 C2 specifically aims to mitigate the risk of electrical shock by ensuring that the grounding path is established before any other electrical connection is made. This ground first principle is a cornerstone of electrical safety practices worldwide. In addition to the safety benefits, the specified orientation offers practical advantages. The placement of the grounding prong at the bottom facilitates easier insertion and removal of plugs, especially in situations where space is limited or the receptacle is difficult to reach. This seemingly minor detail can significantly improve usability and convenience, particularly for individuals with limited dexterity or mobility. From an aesthetic perspective, the vertical orientation with the grounding prong at the bottom presents a cleaner and more visually appealing appearance. The grounding prong is partially concealed behind the faceplate, creating a more streamlined and less cluttered look. While aesthetics may not be the primary concern in electrical installations, it is a factor that contributes to the overall quality and professionalism of the work. While the NEC provides clear guidance on the orientation of receptacles, there may be instances where strict adherence to the code is not feasible due to site-specific conditions. However, in such cases, it is crucial to prioritize safety and ensure that the grounding path is properly established using alternative methods. This may involve consulting with a qualified electrical inspector or engineer to develop a solution that meets the intent of the code while addressing the unique challenges of the installation. The grounding terminal's position being at the bottom ensures the grounding prong makes contact first, reducing electrical shock risks. Beyond the NEC code specifications, vertically installing grounded 110-volt receptacles with grounding prongs below line 1 and neutral spade inserts is common. This practice is upheld for safety, convenience, and aesthetics. Safety standards ensure proper grounding, decreasing electrical shock risks. Convenience is improved by making plugging and unplugging easier due to the accessible grounding prong at the bottom. A better visual appeal results as the grounding prong is somewhat hidden by the faceplate. Some situations might require horizontal receptacle installation due to space or other reasons, but code compliance means the grounding prong must still be at the bottom. Section 406.4 C2 of the NEC explains how faceplates for flush-mounted receptacles or switches need installing. The grounding terminal should be at the bottom. By making sure the grounding prong is first to touch the receptacle, the risk of shock reduces. The vertical installation with the ground pin downward is not just a convention. It's a safety measure to ensure electrical grounding happens before other connections. This minimizes shock risks. Easy plug insertion/removal is another benefit, especially in tight spaces or hard-to-reach areas. It's visually cleaner because the ground pin is partially hidden by the faceplate. The NEC prioritizes safety above all. However, exceptions to the vertical installation might occur due to layout constraints. Even then, ensure the ground is properly installed to meet NEC safety intentions. Always seek advice from qualified electricians or inspectors to navigate unique installation problems, ensuring safety and code compliance. The purpose of Section 406.4 C2 in the National Electrical Code is to reduce the risk of electrical shock during the use of electrical receptacles. This is achieved by dictating the orientation of the grounding terminal on flush-mounted receptacles, mandating that it be located at the bottom. This arrangement ensures that the grounding prong of an electrical plug makes contact with the grounding terminal of the receptacle before any other prongs make contact with their respective terminals. This ground-first connection is critical for safety because it provides a path for any fault current to flow back to the source, tripping the circuit breaker and interrupting the flow of electricity before a dangerous shock can occur. The grounding system is designed to protect individuals from electrical shock by providing a low-impedance path for fault currents. When a fault occurs, such as a wire coming loose and contacting a metal enclosure, the fault current will flow through the grounding system back to the source. This high current will quickly trip the circuit breaker, cutting off the power and preventing a shock. Without a properly installed grounding system, the fault current could flow through a person who comes into contact with the energized enclosure, resulting in a serious or even fatal electrical shock. The NEC requirement for the grounding terminal to be located at the bottom of the receptacle is not just an arbitrary rule. It is based on sound engineering principles and years of experience in preventing electrical accidents. By ensuring that the grounding connection is made first, the risk of shock is significantly reduced, making electrical systems safer for everyone. The grounding system is a critical component of any electrical installation, and it is essential to ensure that it is properly designed, installed, and maintained. Regular inspections and testing can help to identify potential problems before they lead to serious accidents. The NEC provides detailed guidance and the requirements for grounding systems, and it is important to follow these guidelines carefully to ensure the safety of electrical systems. In addition to the safety benefits, the specified orientation of receptacles also offers practical advantages. The placement of the grounding prong at the bottom facilitates easier insertion and removal of plugs, especially in situations where space is limited or the receptacle is difficult to reach. This seemingly minor detail can significantly improve usability and convenience, particularly for individuals with limited dexterity or mobility. The grounding prong serves as a guide, aligning the plug with the receptacle and ensuring that the prongs are properly inserted. This reduces the risk of damaging the receptacle or the plug, and it makes it easier to plug in devices in dimly lit areas or when one's vision is impaired. Furthermore, the vertical orientation with the grounding prong at the bottom presents a cleaner and more visually appealing appearance. The grounding prong is partially concealed behind the faceplate, creating a more streamlined and less cluttered look. While aesthetics may not be the primary concern in electrical installations, it is a factor that contributes to the overall quality and professionalism of the work. A well-designed and properly installed electrical system should not only be safe and functional but also visually appealing. The consistent orientation of receptacles throughout a building can enhance the overall aesthetic and create a more cohesive and professional appearance. The NEC recognizes that there may be instances where strict adherence to the code is not feasible due to site-specific conditions. For example, in some cases, space constraints may make it impossible to install a receptacle vertically with the grounding prong at the bottom. However, in such cases, it is crucial to prioritize safety and ensure that the grounding path is properly established using alternative methods. This may involve consulting with a qualified electrical inspector or engineer to develop a solution that meets the intent of the code while addressing the unique challenges of the installation. The NEC allows for some flexibility in the application of its rules, but it always emphasizes the importance of safety. Any deviation from the code must be carefully considered and justified, and it must be implemented in a way that does not compromise the safety of the electrical system. When installing a 110-volt receptacle, Positioning it vertically with the grounding prong below the line 1 and neutral slots is a common and codified practice. Section 406.4 C2 of the National Electrical Code stipulates this orientation. The NEC states that faceplates for flush-mounted receptacles or switches must be installed so the grounding terminal is at the bottom. This rule ensures safety by having the grounding prong make contact first, reducing electrical shock risks. Grounding first provides a safe path for fault currents. This practice isn't just about code compliance. It's also about safety, convenience, and aesthetics. Safety is enhanced by the ground first connection. Convenience is improved by easier plug insertion and removal. Aesthetics are addressed by a cleaner look, with the grounding prong partially hidden. The NEC mandates that the grounding terminal on flush-mounted receptacles be at the bottom. This helps reduce shock by ensuring ground contact before other connections. This is the ground first design. The grounding system guides any fault current back to the source, tripping the breaker and cutting power to avoid electrical shock. The orientation facilitates easy plug insertion/removal, especially where space is tight. A cleaner look is achieved because the ground pin is partially hidden by the faceplate. Though the NEC offers some flexibility, the primary focus is always safety. Deviations from code must be carefully thought out, ensuring no compromise in electrical system safety. The code exists to protect people and property from electrical hazards.